The number at the top of the first page was $14 million. I had looked at numbers on documents before, estimates, invoices, repair orders, the occasional insurance claim, but a number like that on a document with my name on it was a different category of experience entirely, and I want to be honest with you about what it felt like, which was not what I expected. It felt like confirmation, not surprise, not disbelief. The specific quiet feeling of a thing that has been true for a long time finally being written down somewhere official. It was a Monday morning in early May 2024 in a conference room on South Boston Avenue in Tulsa, Oklahoma. Carol Yates was beside me with her own copy of the documents, already reviewing the manufacturing rights clause for the second time because Carol reviewed everything at least twice, and the things that mattered she reviewed 3 times. Walt Pruitt was across the table from the Meridian Energy Solutions legal team, shaking hands with a man named Robert Hale, who had been his colleague at a Tulsa oilfield equipment manufacturer 17 years earlier, and who was now, in the specific irony of these transactions, the man who had decided that what I had built in my garage on Archer Street was worth $14 million to his company. Miles was in the waiting area outside with his engineering notebook. He was 12 years old, and he had been keeping that notebook for 3 years, since I had given it to him when he was 9, and he had started asking questions about engine systems that I realized were better answered in writing than in speech. He was reviewing his own notes from the previous 2 months in the waiting area, the way he reviewed everything, carefully, page by page, not skipping anything. 2 months earlier, on a Monday morning in March, a woman named Renee Stafford had pulled up to Calloway Engine Works on Archer Street with 2 flatbed trucks and 20 broken engines she had no room for in her warehouse. She had her warehouse manager with her and 2 clients she was showing the Tulsa operation to. She had a story prepared. She delivered it in front of my one employee and in front of Miles, who was at the shop that day because his school had a professional development day, and Miles always chose to come to the shop on days he didn't have to be anywhere else. She said she was doing me a favor, that Stafford Industrial had surplus inventory and that a shop like mine could probably use the material. Miles looked up from his notebook when she said it. He looked at her. He looked at me. I said, "Thank you." I was already walking toward the first engine on the flatbed. What Renee did not know, what no one had known except me, and even I had not known it completely until I had 20 engines to work with, was that the specific combination of engine types in that delivery gave me what I had been missing for 12 years. The raw material to build the prototype of something I had been theorizing about since a pump jack operator named Gary Briggs had walked into my shop in the fall of 2012 with a burned piston and a problem that nobody in the oilfield business had solved economically. Every pump jack operator in Oklahoma had been looking for that solution for 20 years. Meridian Energy Solutions found it on Archer Street in Tulsa for the cost of hauling 20 broken engines across town. Robert Hale signed the documents at 10:47 a.m. I signed at 10:49. Carol signed as witness at 10:50. I went to the waiting area and told Miles we were done. He closed his notebook. He said, "Did they sign?" I said yes. He said, "Good." He put the notebook in his jacket pocket. "Can we get lunch?" We got lunch. I need to tell you about my father first, because the notebook and everything that came from it starts with him. Leonard Calloway ran a small engine repair shop out of the detached garage behind our house in the Greenwood neighborhood of Tulsa for 31 years. Not a commercial operation with a sign and a phone number in the yellow pages. A neighborhood shop, the kind of place that existed in every community before the chains made them unnecessary, where people brought the things that had stopped working because they trusted the man who would look at them. My father fixed lawnmowers and generators and small industrial equipment and the occasional pump jack engine that an operator would bring in from the field when the problem wasn't worth calling the manufacturer's service line. He charged fair rates. He used only the parts he needed. He told people the truth about what was wrong and what it would cost and whether it was worth fixing. In 31 years of doing this, he built a reputation in North Tulsa that was, in its own way, more valuable than any certification or credential. The reputation of a man whose word about a mechanical problem was reliable. I grew up in that garage, not visiting, not playing nearby, present and useful from as early as I can remember. By 10, I could disassemble and reassemble a small engine correctly. By 14, I was doing complete overhauls that my father brought me because he trusted my hands. By 17, I was the one he came to when a diagnosis wasn't coming together. Not because I was smarter than him, but because I had a different kind of patience with problems that didn't reveal themselves quickly. I was willing to sit with something until it showed me what was wrong, rather than reaching for the most probable answer. My father had a stroke in 2008 at 63 years old. He could no longer work. I ran the garage alone for 2 years, continuing the same work at the same address in the same way he had done it, and then I moved the operation to a leased space on Archer Street in 2010 and opened Callaway Engine Works under my own name. I was 26 years old. I kept the same philosophy my father had kept for 31 years. Look at what's there. Write down what you find. Fix what can be fixed. Tell the truth about what can't. I met Paula in 2007. We married in 2009. Miles was born in 2012. Paula died in 2019 from ovarian cancer, 11 months from the diagnosis call on a Wednesday afternoon to the end. Miles was 7 years old. I closed the shop for 3 weeks. Then I opened it again because Miles needed a father who was present and working, and the shop was the one place in my life where every problem had a solution if you were patient enough to find it, and that was what I needed to believe in 2019. Miles grew up at Callaway Engine Works the way I grew up at my father's garage. Present, useful, genuinely capable by the time he was old enough to hold a tool correctly. By 12, he understood compression ratios, fuel delivery systems, and basic ignition timing. He had his engineering notebook, a wire-bound thing I had given him when he was 9 after he had asked me a question about carburetor jet sizing that I realized deserved a more thorough answer than I could give verbally. I said, "Write it down. We'll work through it together." He wrote it down. He never stopped. He called the shop the lab. He had called it that since he was old enough to understand what labs were for. I never corrected him. It was not incorrect. I'd been thinking about the wellhead gas problem since 2012. It had started with Gary Briggs. Gary ran 14 independent pump-jack wells in Osage County northwest of Tulsa. Modest wells producing modest volumes of oil with the kind of economics that required every cost to be scrutinized and every saving to be captured. He walked into Callaway Engine Works in the fall of 2012 with a burned piston from a small pump-jack engine and a problem he had been living with for 3 years. He wanted to run his pump jacks on wellhead gas. Wellhead gas, also called casing head gas or associated gas, is the natural gas that comes up with the oil in producing wells. On Gary's wells, it came up in sufficient volume to be useful. It was free because it was already there, and it would otherwise have to be flared off or captured by a pipeline company that took a cut of its value. Running his pump-jack engines on it instead of diesel would save him thousands of dollars a month across 14 wells. The economics were obvious. The problem was equally obvious. Raw wellhead gas is not processed gas. Its BTU content varies, sometimes rich with heavier hydrocarbons, sometimes lean when the reservoir changes composition. Its pressure at the wellhead varies, high in the morning when temperatures are cold, lower in the afternoon when surface lines warm up and expand. It carries water vapor and occasionally heavier liquid fractions. Carburetors calibrated for diesel don't work for gas. Carburetors calibrated for clean processed propane don't work for raw wellhead gas. The ignition timing that works for diesel doesn't work for gas. Every time Gary or operators like him had tried to run engines on raw wellhead gas, they had failed within weeks. Burned pistons like this one, lean seizures on cold mornings, rich fouling when the BTU content spiked. I looked at Gary's burned piston for a long time. I fixed the engine correctly. Gary went back to diesel, and I went back to the shop and opened a new notebook. Not a casual notebook, a working notebook, the kind where you write down every observation, every calculation, every partial solution and its specific failure mode, every question that the partial solution raises. I filled it over 12 years. Not continuously. There were months when I didn't add anything because the immediate work of the shop didn't leave room for it. But the thinking was always there, the way certain problems stay with you and surface when you're doing something else and you find yourself reaching for the notebook. The core problem, as I understood it after 3 years of thinking about it, was this: a system that could run a pump jack engine on raw wellhead gas needed to do two things simultaneously that existing technology could not do simultaneously. It needed to vary the fuel-air mixture in real time as the gas composition changed, which required a carburetor with a self-regulating secondary fuel circuit rather than a fixed jet calibration. And it needed to adjust ignition timing in real time as the combustion characteristics of the variable gas changed, which required a vacuum advance mechanism responding to manifold pressure changes that correlate with the combustion characteristics of the variable gas, rather than running a fixed timing curve. Both technologies existed in partial form in various engines for various applications. Nobody had combined them specifically for the wellhead gas problem in a package that was small enough, simple enough, and cheap enough to retrofit onto existing pump jack engines in the field. I had been writing about why and sketching possible approaches and identifying the specific components that might work since 2012. By 2024, I had 411 pages of notes. What I did not have was the engines to build a prototype, until March. Renee Stafford had founded Stafford Industrial Supply in Tulsa in 2005 at 32 years old. Industrial equipment, tools, supplies, and service contracts for oilfield operations across northeastern Oklahoma. 38 employees. A reputation in the Tulsa industrial community built on volume and reliability. She was not an engineer. She was a business person who operated in the industrial world. She understood what equipment cost and what it was worth in the market and how to move it efficiently. What she did not understand, and had no reason to have understood, was what specific combinations of broken engines might be worth to someone who had been thinking about a specific engineering problem for 12 years. In 2022, I had declined a subcontracting arrangement from Stafford Industrial at a rate she had proposed that I had assessed as below the cost of doing the work correctly. I had said so directly. She had not forgotten. In late February 2024, Stafford Industrial had a floor space problem. A large customer return, 20 industrial engines of various types and conditions, all non-running, was taking up bay space she needed for incoming inventory. She told her warehouse manager to arrange the delivery and called two clients she was showing the Tulsa operation to, prospective accounts from Oklahoma City she was working to convert, and suggested they could stop by Calloway Engine Works on the way to lunch. She arrived on a Monday morning in March with her warehouse manager and two prospective clients, with the performance of someone doing a favor they have staged for maximum visibility. Miles was at the back bench when the flatbeds pulled in. School had a professional development day. He was reviewing notes he had made on a carburetor rebuild I'd walked him through the previous weekend, the kind of focused Saturday morning work we did together regularly, where I would explain something in detail and he would write it down and come back to it the next day to make sure he had understood it correctly. He heard the trucks. He heard Renee's voice. He did not put down his notebook. I came out of the shop and listened to what she had to say. I looked at the 20 engines being unloaded. I looked at Renee. I said, "Thank you." She said something to her clients as she walked back to her Suburban. Her warehouse manager heard it. It traveled through the Tulsa industrial community the way things travel in small industries, not loudly, not immediately, but reliably. Miles looked up from his notebook when I came back inside. He looked at the engines in the lot. He looked at me. He said, "Are these useful?" I was already walking toward the assessment bay. I said, "Get your notebook." I spent the first 4 days on systematic assessment. 20 engines photographed, measured, documented. Failure mode identified where I could determine it. The collection was varied. 6 small single-cylinder industrial engines, 4 V-twin utility engines, 3 inline 4-cylinder engines from light industrial equipment, 4 larger single-cylinder engines from pump jack applications, and 3 medium-bore V8 engines from oilfield equipment that I recognized as the same basic platform I had worked on for pump jack operators for 15 years. It was the 3 V8S and the 4 pump jack single-cylinders that stopped me on the 4th day. I arranged them on stands in the main bay. I sat down in front of them with my notebook, the original one from 2012, along with the 6 subsequent volumes I had filled in the years since. I went through the pages, I looked at the engines, I went through the pages again. Then I called Walt Pruitt. Walt was 63 years old and had spent 28 years as a mechanical engineer at a major oilfield equipment manufacturer in Tulsa, working specifically on pump jack drive systems and the engines that powered them from 1985 until his retirement in 2013. He lived next door to me on Jasper Avenue. We had been neighbors since 2015, and what had started as conversations over the back fence had become, over 9 years, something closer to a working partnership. He had read my wellhead gas notebook in 2021. I had handed it to him on a Sunday afternoon and asked for an engineer's opinion on whether the theory was sound. He had taken it inside and come back Monday morning with 3 pages of his own notes. He had said, "The theory is sound. Your carburation approach is close. Your ignition timing is wrong, and that matters more than the carburation." He had explained why in the patient and specific way of someone who has spent 28 years thinking about exactly this type of problem. We had talked about it periodically since. Neither of us had had the specific engines needed to prototype it. Walt arrived the morning after I called. He looked at the 7 engines, the 3 V8S and the 4 pump jack singles, arranged in the bay. He looked at me. He said, "Tell me what you're thinking." I told him. What I had identified in the 4 days of assessment was this. The V8 carburetor housings could be modified to accept a secondary fuel circuit controlled by a spring-loaded pressure diaphragm, a self-regulating secondary jet that would adjust fuel flow based on incoming gas pressure rather than requiring a fixed calibration, not a complex modification, a specific one. The pump-jack single-cylinder magneto-ignition systems had an architecture that could be modified with a vacuum advance mechanism responding to manifold pressure changes that correlate with the combustion characteristics of the variable gas, adjusting timing appropriately as the gas composition shifted rather than running a fixed timing curve. Either modification alone did not solve the wellhead gas problem. Together, integrated into a single system and calibrated against the range of wellhead gas compositions I had documented from conversations with pump jack operators over 12 years, they might. Walt listened without interrupting. When I finished, he was quiet for a moment. Then he said, "The pressure diaphragm approach. I proposed something similar at the manufacturer in 1997. Management killed it before testing. Diesel margins were good, and they didn't see the market for a gas alternative." I said they were wrong about the market. He said, "Yes, they were." He looked at the engines. "Let's build it." The build took 4 weeks. I led. Walt provided the engineering precision that 28 years of professional work in oilfield equipment provides, the ability to calculate tolerances correctly, specify materials correctly, document the system in the formal language that a patent application requires. Miles was there every afternoon after school and all day on weekends. He did not do the critical work alone, but he was genuinely useful, holding components, reading measurements, tracking the documentation in his own notebook in parallel with the formal record we were building for the patent. He asked questions the way he did everything, methodically after he had thought about them, in the order that made logical sense rather than the order they occurred to him. Some of his questions were ones I had not thought to ask. A 12-year-old who has been paying careful attention for 3 years sometimes sees things that the people who built the system have stopped seeing. The prototype combined components from 4 of the 7 engines, the best carburetor housing from one of the V8S, the best magneto and advance mechanism from one of the pump jack singles, a custom-machined pressure diaphragm that I produced on the CNC mill I had purchased in 2018, the best capital investment I had ever made, bought with a small business loan that I had paid off in 2 years, a fuel delivery manifold that Walt designed from scratch and that I fabricated over 3 evenings. Carol Yates filed the provisional patent application on April 10th, day 38, after Walt had prepared the technical documentation and I had verified its accuracy, and Carol had translated it into formal patent claim language with the systematic efficiency of someone who had been doing this for 18 years. The filing established the priority date. The technology was protected from that morning forward. We tested the prototype on April 3rd, day 30, connected to a propane supply at various pressures and compositions simulating the range of wellhead gas conditions I had documented. It worked. Not perfectly on the first run. There was a lean condition at the lowest pressure setting that required 4 additional days of carburetor adjustment to resolve. But the fundamental principle was confirmed from the first test. The system self-regulated. The secondary fuel circuit responded to pressure changes the way the diaphragm was designed to respond. The vacuum advance mechanism adjusted timing appropriately as manifold pressure shifted with changes in gas composition. The engine ran at the low pressure setting, the high pressure setting, and the intermediate settings without fault. Miles documented every test result in his notebook, every pressure setting tested, every adjustment made, every result observed. His documentation was more complete than the formal record in some respects because he was recording everything he saw rather than only the data points we had specified to capture. On the evening of the first successful test, Walt and I sat at my workbench with coffee and Miles sat across from us with his notebook still open. The shop was quiet. Tulsa was doing what Tulsa does in early April. Cool in the evenings still, the last of winter holding on at the edges of the days. Walt looked at his coffee. He said, "We should call Gary." I said, "Already did." Gary Briggs drove in from Osage County on April 15th with a sealed sample container of actual wellhead gas from one of his producing wells. He had heard through the Tulsa oilfield community, because information in the Tulsa oilfield community moves with the efficiency of a system designed specifically for that purpose, that something was happening at Calloway Engine Works related to the wellhead gas problem. He had called me directly. I told him a sample would be useful. We ran the system on Gary's wellhead gas for 4 continuous hours. Miles sat in the shop the entire time. He sat in his chair at the back bench with his notebook, and he documented every 15 minutes of the test. The pressure reading, the temperature, the engine behavior, anything he observed. He did not say anything for most of the 4 hours. Near the end of hour 3, he made a note and looked at it for a moment and then looked at the engine and then made another note. At the end of hour 4, the engine was still running. The system had self-regulated through 3 distinct pressure variations in Gary's wellhead gas sample without manual adjustment and without fault. Miles looked at me. He said, "It works." I said, "Yes." He wrote that down. 2 words, at the bottom of the page with the hour 4 data in his careful 12-year-old handwriting. "It works." Gary Briggs stood near the engine for a while after the test. Then he looked at me and said, "How soon can I have this on a well?" I said, "Talk to Carol." Walt had been making calls since the first prototype test on April 3rd. Not publicly, not announced, not posted anywhere. Quietly, through the network of retired and active oilfield engineers that a man accumulates over 28 years in the industry. The kind of network that exists entirely outside formal channels and moves information with a speed and specificity that no press release or trade publication can match. He had identified 3 potential buyers. 2 were large manufacturers. Their acquisition processes would take 6 months minimum, and their legal review would require documentation we would not have ready for months. The 3rd was Meridian Energy Solutions in Oklahoma City, a mid-size oilfield equipment company with 60 employees and a specific history of acquiring field-developed technology and bringing it to commercial production. Their CEO was Robert Hale, who had been Walt's colleague at the Tulsa manufacturer before Robert had left to join Meridian in 2007. Walt called Robert on April 16th, the morning after Gary's test. He described the system, he described the 12 years of documentation behind it, he described the prototype test results, he described me and Calloway Engine Works and the notebook. Robert Hale said, "How soon can I see it?" He came on April 22nd with his chief engineer Sandra Lau, 22 years in oilfield equipment design, the kind of engineer who looks at a prototype the way someone who has spent 2 decades designing field equipment looks at a prototype, with the specific focused attention of a person evaluating something against a very precise internal standard. Sandra Lau spent 90 minutes with the prototype and the documentation. She went through Walt's technical specifications page by page. She ran the system herself, adjusting the supply pressure through its full range, watching the secondary circuit respond and the timing advance and retard with the changing manifold pressure. She examined the machining on the custom diaphragm with the attention of someone who could assess machining quality by looking at it, which she could. She went outside and made a phone call. She came back in. She looked at Robert Hale and said 4 words. "This is the one." Robert looked at me. He said, "What are you asking?" I looked at Walt. Walt gave me the specific expression of a man who has been in negotiations before and knows when the room is ready. I said the number. $14 million. Full assignment of the patent application and all related intellectual property. Manufacturing rights. The prototype. I retained the right to use the technology for service work in my own shop. I was not going to be locked out of applying my own innovation in my own garage. Robert said, "I'll need 3 days." He called back in 2. Carol handled the negotiation with the precision and patience of someone who understood exactly what she was protecting and was not going to move on the things that mattered. The final number was $14 million. The terms I had asked for on the retained service rights were in the agreement without modification. The morning of the signing, Miles sat in the waiting room outside Carol's conference room with his engineering notebook on his knee and reviewed his notes from the previous 2 months. I could see him through the glass from my seat at the conference table. He was on the April 15th pages, the Gary Briggs test. Reading through his documentation the way he read everything, not skimming, going through it. The signatures were applied. Robert Hale shook my hand and then walked to the door and stopped. He looked at Miles through the waiting room glass. He opened the door. He said, "Is that the engineering notebook?" Miles said, "Yes." Robert said, "How long have you been keeping it?" Miles said, 3 years, but my dad has been keeping his for 12. Robert looked at me, then back at Miles. He said, "Don't stop writing in it." Miles said, "I won't." Robert Hale nodded once and walked out. I want to tell you about the phone call I received from Renee Stafford 2 days after the signing. She called on a Wednesday evening. I was in the kitchen finishing the dishes. Miles was at the table doing homework. I picked up on the 3rd ring. She said she had heard about the Meridian transaction. She said she was, and she paused here, looking for the right word in the way people pause when the word they want is not the one they're accustomed to reaching for. Surprised. I said, "The engines were useful." She said, "I can see that now." A pause, not a comfortable one. She said, "I'd like to," and stopped. Whatever she was going to say next she decided was not the right thing. She chose instead the simpler thing. She said, "Congratulations." I said, "Thank you." I ended the call. Miles was looking at me from the kitchen table. He had heard the call from across the room without being able to make out the words. He said, "Who was that?" I said, "The woman who dropped off the engines." He was quiet for a moment. "What did she want?" I said, "I think she wanted to say the right thing. She got partway there." Miles considered this. He looked at his homework. He said, "That counts for something." I looked at him. He was 12 years old and he had his mother's precision and my patience and a specific quality of fairness about people that was entirely his own. I said, "Yes, it counts for something." He went back to his homework. 6 weeks after the signing, a Saturday morning in late June 2024. Walt was at the shop. He had been at the shop most mornings since March, the same habit that established itself during the build and continued because neither of us had any particular interest in stopping it. Miles was at the back bench with his engineering notebook open to a new section. He had been working on a modification to the primary system, a pressure equalization approach in the secondary fuel circuit that he believed would improve cold start performance at temperatures below freezing. He had not told me about it yet. He had been working through the theory first, the way I had always worked through theory first, getting it right in the notebook before bringing it to the bench. I was at the primary workbench reviewing the technical specifications for the commercial version of the system that Meridian's engineering team had sent for my input. A condition of the IP agreement that I would have the right to review the commercial implementation before it went to production. I was going through it page by page with a pencil making notes in the margin. There were 6 things I wanted to flag. I had found 4 of them and was looking for the other 2. Walt brought coffee. He set 1 cup beside me and 1 beside Miles without being asked, and sat on the stool at the end of the bench with his own. He looked at Miles working in the notebook. He watched him for a moment. He said, "What are you working on?" Miles said, without looking up, "Cold start improvement, secondary circuit pressure equalization." Walt was quiet. He looked at the notebook from across the bench. He said, "Show me." Miles turned the notebook so Walt could read it across the bench. Walt read for 2 minutes without speaking. He looked at the calculation on the 3rd page. He looked at the diagram on the 4th. He looked back at the calculation. Then he said, "This might work." Miles said, "I know. That's why I'm working on it." Walt looked at me. I had not looked up from the meridian specification, but I was not reading it anymore. I was listening. Walt looked back at Miles. He said, "Your father kept a notebook for 12 years before anyone paid attention to it." Miles said, "I know." Walt said, "Keep writing." Miles said, "I know." He turned the notebook back toward himself and went on with the calculation. Outside on Archer Street, Tulsa was doing what Tulsa does on a late June morning, hot and flat and full of light, the specific quality of Oklahoma summer that settles into everything and makes the ordinary look exactly like itself, no more and no less. The shop smelled like it always smelled. The engines on the assessment rack were 3 new units that had come in that week: a pump jack engine from an Osage County operator, a generator from a construction site in Broken Arrow, a small industrial unit from a manufacturing plant in Sand Springs. Ordinary work. The kind that keeps a shop running and that I find as satisfying as any other work because it is the work my father did, and his standard was the right standard. I found the 5th thing I wanted to flag in the meridian specification and noted it in the margin. Some problems wait 12 years for the right set of parts to arrive. Some solutions get delivered to your door by someone who thinks they are doing you a disservice. Some things get handed to you as a way of diminishing you and turn out to be the exact components you needed to build the thing you had been working toward your entire career. The notebook knew the answer before the engines arrived. The engines just made it possible to prove it. Miles was still writing. He had 3 pages left in this section before he would need to start a new one. He was working on the next thing. "Before you go, I want to ask you something. Is there a problem you have been thinking about for years? Something you keep coming back to? Something you have pages of notes about that nobody else has seen yet? That you have not been able to finish because you didn't have the right materials or the right moment? Because sometimes the materials arrive in a form you didn't expect. What are you still working on? Tell me in the comments. I read every single one. If this story stayed with you today, share it with one person who needs to hear it. You already know who that is. And if you're new here, subscribe. Every week, a story like this one. Real people. Real decisions. The kind that stay with you.